morning. I know normally we try to do this at noon, so this was a little bit earlier for us, but we are so proud to bring this presentation to you. And again, we are very thankful to our partners at Virginia Mason. Before we get started, I have a couple of announcements about our EQUIP program. Last month during our collaborative call, we talked about getting a collaborative site uploaded so that we could all share information, and we're very pleased to say that we are ready to go live with that. Over the next week or two, you should be getting an email from Intermedia Services that will say that you've been registered as a user with QH Host Pilot EQUIP. That's going to be your login information. You'll also get a follow-up email from me with your login information and your password. So look for 2 emails over the next week or so. And to make sure that everybody knows how to use that site, which is where we are going to post the recording of today's webinar and next week's webinar in our SharePoint site, we are going to have a very brief webinar to introduce you and orient you to that SharePoint site, and that's going to be Friday, October 16th at noon. So more information will be coming out about that, but we're really excited to get that off the ground. More to come. So this morning, I am very pleased to introduce you to Virginia Mason's Sterile Processing Department. These partners have just been a wonderful group of people to work with, and we have with us today Sam Luker. He is the Director of Sterile Processing at Virginia Mason. He's also the President of the Pacific Northwest International Association of Healthcare Central Service Material Management. Sometimes you'll hear it called ISHM. And he is here to support Kelly Gordley, who is the educator for the Virginia Mason Sterile Processing Department. Kelly is a certified registered central sterile technician, and she has quite a great story that I'm going to introduce you to. So in 2008, Kelly found herself as a patient undergoing a major complex spine procedure. And during this time, she lost her livelihood, and without the support of her family, she would not have been able to endure or complete her recovery process. She was quite grateful for the skill of her surgeon and their team of healthcare professionals that helped her with her rehab and her healing. And once recovered, Kelly was ready to get back into the workforce. She began to research educational opportunities in healthcare and found the profession of sterile processing technician. She knew that after her healing journey and what she had been through, sterile processing was what she wanted to do. She attended Renton Technical College and finished her Central Sterile Technician program. She was hired directly from school at Virginia Mason Medical Center in 2010. She's been a sterile processing technician for the past 5 years, and as I said earlier, she is now the educator for the Sterile Processing Department. Her professional interests focus on attention to detail and ensuring that each item that will be used in patient care is safe and ready to use. It is Kelly's passion to provide the best patient care possible in a department that plays such a vital role in the patient experience. So I'm going to turn this over to Kelly. She's going to go over the principles and practices of high-level disinfection. We're going to follow this webinar next week on October 8th with Sarah Wilkerson, who's also on the line with us today. She's an infection preventionist with Virginia Mason. And Sarah, next week, will go into a little bit more detail about what infection preventionists need to be looking for in assessing high-level disinfection. At the end of this presentation, we'll have an opportunity for you to ask questions. And, of course, you can always submit your questions by chat or by email as well. So with that, Kelly, take us away.
All right. Thank you, Jamie. Appreciate it. Good morning, everybody, and thank you again for the opportunity to be here. We appreciate this. We're going to go ahead and get started kind of with the principles and practices of effective high-level disinfection this morning. So this first slide is our organizational goals here at Virginia Mason. This kind of steered us into, I guess, writing a high-level disinfection program that focuses on the patient as our top priority. We realized we were doing a lot of good things, but there's always room for improvement to strive for best practice. So our objectives this morning for this discussion is first we'll start with reviewing the Spaulding Classification. We're going to define and understand the difference between what is sterile and what is high-level disinfection. We're going to understand the important steps of manually cleaning a reusable medical device before the high-level disinfection process, understand the importance of the ST58 and recommended standards, understand different types of high-level disinfectants that are on the market, understand the health and safety considerations when using high-level disinfectants, understand proper environment for high-level disinfection processes, know and understand the importance of proper documentation for high-level disinfection, and understand the importance of staff training and documentation of that training. So we'll go ahead and get started. All right, first let's review the Spaulding Classification. It's broken down into 3 categories. The first is critical devices. These devices enter sterile tissue, which would probably be surgical instrumentation such as needle holders, scissors, clamps, anything that's introduced into the bloodstream, and these items must be sterile when used on a patient. Then we have our semi-critical devices, and these devices come into contact with intact mucous membranes or non-intact skin, and those require a minimum of high-level disinfection to be rendered safe for patient use. And then we have our non-critical devices, and those come in contact with intact skin, and they only need sanitation. So those would be your stethoscopes, blood pressure cuffs, for example. Next is, what is the difference between sterile and high-level disinfectant? So we're going to kind of break down those definitions, which is an important definition to know in the sterile processing world. Sterilization is the process by which all forms of microbial life, including bacteria, viruses, fungi, and bacterial spores, are completely destroyed. So these would be items that are considered critical devices that do come into contact with sterile tissue or the vascular system. These items must be sterilized. With disinfection, this process kills microbial organisms, but not necessarily large numbers of bacterial spores. So these would be for devices that are considered in the category of semi-critical devices. They come in, again, with contact with intact mucous membranes, and they can be high-level disinfected, but sterilization is preferred for best practice. Endoscopes are considered semi-critical devices, and they are very complex biomedical devices, and as we all know, that they've gotten a lot of hot attention in the news as of lately. So outbreaks associated with flexible endoscopy have most often been associated with breaks in either the cleaning or the high-level disinfection or the sterilization stage of flexible endoscope reprocessing. So the reprocessing protocols provide a very narrow margin of safety, and any slight deviation from these recommended steps may result in increased risk of infection transmission of flexible endoscopes. So listed here in bullet points are some of the common errors that are associated with reprocessing of flexible endoscopes. Failure to perform leak testing prior to the manual cleaning process. Also failures in completely immersing the endoscope during the manual cleaning process. Inadequate exposure time to enzymatic detergent during the cleaning process. And that's usually gone by, you look at your manufacturer's instructions for use per the detergent that you are using for the correct amount of contact time. An example we've deployed here in our organization is that we have a timer set at the sink for manual cleaning. Our detergents require a 5-minute contact time for soaking during the manual cleaning process, so our technicians have to set a 5-minute timer to ensure that proper amount of contact time. Also, inadequate amount of active ingredient used for the disinfectant, inadequate volume of water used for rinsing, time for scopes drying prior to storage, and the placement of valves on the endoscope during storage. So anytime an endoscope is stored, it has to be vertically hanging in a scope cabinet, and all of the valves, buttons, and also the water-resistant caps should be removed during storage. Just some of the points on that. Sterile processing staff must follow all recommended manufacturers' cleaning instructions for cleaning flexible endoscopes. Basic steps in the reprocessing is bedside cleaning or point-of-use cleaning. This kind of starts the whole process of having the whole reprocessing be a success. I believe that the end user does have a big responsibility, whether it be in the clinics or in the OR, wherever these devices are being used, that ensured point-of-use cleaning is happening on these devices. Once it's transported to the decontamination, that proper leak testing, thorough manual cleaning, rinsing, the high-level disinfection process, again, rinsing, proper drying, and storage of the device is all complete. Note that this is kind of the oversimplification. This could involve a lot of different steps, and we could hang our shingle just on this slide alone and do like a whole other presentation on cleaning of flexible endoscopes and this process. There we go, next slide. So cleaning of flexible endoscopes and also reusable medical devices is the first and most important step. So whether it be TE probes, PMB probes, CMAC blades, anesthesia equipment, whatever item it is that you are high-level disinfecting, thorough cleaning of these items is an important initial step in any of the high-level disinfection processes that you are doing. A quote from our certification organization, ISHM, out of their textbook is, "One can clean without sterilizing or high-level disinfecting, but one cannot sterilize or high-level disinfect without cleaning." Cleaning is the most important part, or the first steps in all this processing. So cleaning is intended to remove all foreign matter, such as blood, tissue, protein, etc., from the medical device. If adequate cleaning cannot be achieved, then subsequent high-level disinfection or sterilization procedures are likely to be rendered ineffective. Cleaning of flexible endoscopes, again, PMB probes, T probes, CMAC blades, LMAs, glidoscopes, the list goes on to what our technicians get a hold of and process. But processing personnel should visually inspect each of the items carefully to detect any visible soil. So after the manual cleaning process, that visual inspection is important to ensure that any gross bioburden that is left on is found, and if it is still on the device, then the manual cleaning process should start again. Sometimes inspection using magnification might identify any residues more readily that will help the unaided eye, and visual inspection alone sometimes may not be sufficient for assessing the effectiveness of a cleaning process. And why is that important? Is because the organic matter that's left on a device, it can dilute or inactivate active ingredients in a high-level disinfectant, and it will interfere with its contact to the device surfaces. So the high-level disinfectant won't be able to penetrate through any leftover residues or bioburden on the surface of a device. Here's my disclaimer for this. In no way is Virginia Mason endorsing specific vendors, manufacturers, or products. The pictures that I've put in this slideshow today are just instruments or equipment that we have purchased for use within our organization to help aid in a successful scope or medical device safe for patient use. So these are tools and devices that we've used to help us achieve best practice. Again, there's lots of different items on the market, different manufacturers. Shop around and see what it would work best with your particular organization and your HLD program. But these are some tools that our sterile processing has implemented to ensure clean and safe scopes and items that are recommended for best practice. We use a flushing device. There are many on the market. We particularly here, we use the Scope Buddy from Medivator. It has cleaning adapters that are hooked up to flexible endoscopes that have working channels, and it has a certain amount of pressure that will flush those channels with enzymatic detergent as well as rinse water. Once we manually clean a flexible endoscope or other item that's ready for high-level disinfection process, we use ATP testing. And basically what that does is a swab device. You'll swab the channel of the endoscope or the distal end of a TE probe or whatever it is you're testing. And then the reader will be looking for the ATP molecule, which is basically showing you cellular activity. So if it's out of limits, it's telling you that the device probably should go back for manual cleaning, because we're looking to get that proper log reduction of microorganisms off the surfaces of our devices. And then the third product we're using is an AER. We're using the Medivator Advantage Plus. Again, there's many different devices as far as AERs on the market that you could use to render your devices high-level disinfected. All right, so now we'll cover the Bible, so to speak, for high-level disinfection and chemicals, is the ANSI/AAMI ST58. It's the national standard, and it provides guidelines for the selection of liquid chemical sterilants or high-level disinfections, also gaseous chemicals sterilizers that have been cleared for marketing by the Food and Drug Administration for use in hospitals or other healthcare facilities. So this program here, we're going to be looking at high-level disinfection chemical sterilization today. A link below here is a link that you could go to purchase this publication. I believe they have it available in hardback or in PDF file. Both are available. And another one of the recommendations is if you are doing high-level disinfection in your organization, it is good to have this publication on hand for reference. So also, this ST58 is going to give you what's available on the market. So products containing the following active ingredients are marketed under various brand names and various concentrations. So again, you'll have your glutaraldehydes, glutaraldehyde with phenol phosphates, hydrogen peroxide, sodium hychlorate. Also, you have your ortho, I'm going to trip over my tongue pronouncing this, phenolaldehyde, which is basically your Cidex or your Cidex OPA, or combinations of your peracetic acid and hydrogen peroxide. The FDA, so the liquid chemical sterilants or high-level disinfection products that have been cleared for market by the FDA are listed below. There's a big long link to that website. So the FDA basically has a list of approved and cleared high-level disinfections or liquid chemical sterilants that are approved for use. This list is updated when new products are cleared, and the information on these approved products is the concentration of active ingredients. It has the sterilization or high-level disinfection contact time, the temperatures, the maximum reuse time and period for each of these products. So when your organization is selecting a high-level disinfectant, there's a few things to keep in mind. So again, has the liquid chemical sterilant or the high-level disinfectant been cleared by the FDA? So that's again where you'd want to go to the FDA website and check that list of approved products. Again, is the system user-friendly? How many steps are involved in the process? That's a good segue, at least, or consideration for sterile processing departments or clinics that are doing this high-level disinfection process, for that system to be user-friendly for the technicians, because we know turnaround times and demands of these devices are in high use, and so if it's a long, lengthy lead time on these devices, or if the process is complicated, it's going to make it difficult for the technicians. Also, has the medical device to be high-level disinfected been validated for efficacy and verified for compatibility with the process? Note that the device manufacturer, whomever that may be, they must provide recommendations regarding which high-level disinfection process has been validated for their device. And also, is there any special preparation needed for the device before processing, like disassembly? Are there parts to be taken off? Does it come apart? Those types of questions should be asked. Next part is our health and safety considerations in using high-level disinfectants. Something to note is what are the potential short and long-term adverse health effects of overexposure to the high-level disinfectant. You'd want to see the SDS sheets. One thing we do here is our technicians work a lot with Cidex OPA, and they have a logbook and where they have to manually write in all the items that is high-level disinfected in this logbook with patient sticker information and the like. I keep that SDS sheet laminated in the back of that logbook, so if they were to be splashed or what have you, that information is at their fingertips at point of use. is the high-level disinfectant potentially toxic to personnel? If it is, in what way? And are there toxic vapors or toxic byproducts? Something to note when you have to dispose of that high-level disinfectant when it becomes expired. Also, does the high-level disinfectant react with certain materials, like cleaning agents, adhesives, to form toxic products? That's definitely questions that you could present to the manufacturer when considering a product for purchase or use. More health and safety considerations. What PPE is required during use? Do high-level disinfectant manufacturers' written instructions for use indicate that the special types of gloves are required when working with the product? So cost can be a factor. So do you need a special respirator, a special mask, specific types of gloves? Would you have to purchase special PPE in order to use this product? More safety considerations. When purchasing a high-level disinfectant for use, what level of in-service instruction or other personnel training in the safe use for chemical does the manufacturer provide? So again, here at Virginia Mason, we use the ASP Cydex OPA as a high-level disinfectant. So they have a manual that's an in-service kit. So it gives you instructions for use. It has sign-off logs. Also comes with an instructional video. Also, you can also contact your manufacturer representative, and they could come to your organization or your facility to actually do personal on-site in-service training for your personnel as well. And again, what level of testing has been done to determine that the processed devices remain safe for patient use after repeated processing? And is it necessary to retain employee health records? If so, for how long? Will there be an eye wash station located close to point of use? Are existing eye wash stations placed appropriately, and are they adequate for high-level disinfectant? I believe Sarah Wilkerson could probably speak more to the types of eye wash stations that they look for that are needed at point of use or close to wherever your processing station with the high-level disinfectants are located. Next, we'll get into environment. One of the recommendations in the ST58 is that a designated area for high-level disinfection is strongly encouraged. Here, we went through a remodel in our department, so we're actually fortunate enough that we were able to create a high-level disinfection room that is dedicated to this process. I know not everywhere will be able to have that luxury, but it is strongly encouraged, or if there's a way to be able to separate a barrier or a section of the department that's dedicated specifically to this, is highly recommended. High-level disinfection should occur in a clean environment to prevent recontamination of a medical device as is removed from the process. So space used for cleaning and decontamination should be separate from the space for high-level disinfection of medical devices. And so these spaces should be separated from patient procedure areas and personnel support areas. So the pictures below kind of show what our environment looks like here in our organization. So we have a decontamination room that has a dedicated sink for cleaning flexible endoscopes and the anesthesia equipment that the technicians handle for the high-level disinfection process. This is where leak testing is performed, the manual cleaning takes place. Once they're finished manually cleaning, there's a pass-through window that these devices go through, and they're passed into the high-level disinfection room. And after the scope is documented, checked for cleanliness, it is loaded into our AER for the high-level disinfection process. All right. Again, material should flow in a one-way direction from the cleaning area to the high-level disinfection area, and then on to storage or distribution. Where possible, solid walls should separate the cleaning area from the high-level disinfected area. In GI endo departments, a separate room for high-level disinfection, again, is strongly recommended. In the sterile processing department, if you're not able to have a separate room, HLD should be performed on the clean side or the prep and pack area, not in the decontamination room. All right. Again, the high-level disinfection environment, the floors, walls, ceilings, work surfaces should be constructed of non-porous material that will withstand frequent cleaning and wet conditions. So here I have a comparison of like what we have here at Virginia Mason, but this is as the after product of our remodel. We have stainless steel walls, sink, basins, all that jazz. That makes it really convenient to be able to do these processes in our decontamination space. But the smaller clinics or other facilities that don't have like a remodeled department or an area like this, you may find, like the picture on your right-hand side, this is actually a dirty utility room in a clinic that is performing manual cleaning of scopes, but their counters are made of the particle board with the laminate material. It's kind of more like office cabinetry. So with these challenged spaces, a lot of technicians are making the best with what they have. So it's trying to, I guess, work within the environment that you have and make it as close to recommendations as you possibly can. Again, here's some more pictures of some challenging environments. The ideal decontamination areas have separation of dirty and clean areas, the walls, pass-through windows, stainless steel work surfaces, sinks, basins, all that. And kind of on the right-hand side are pictures in some clinics that have the space and environmental challenges. So they don't have walls to keep the separation of dirty to clean. Their counters and work surfaces are not constructed of the appropriate material. Then again, that comes into a capital and cost factor of being able to upgrade your environment to make it suitable for the processes that you're doing. Policy and procedures should be standardized throughout the healthcare facility with emphasis on necessary engineering controls, appropriate personal protective equipment, hygiene, and safe work practices. So again, in your environment, you're going to need sufficient space for preparation, quality monitors, chemicals, record-keeping supplies, and hand hygiene facilities. High-level disinfection process should be located in a restricted access area. High-level disinfection should not be performed in high-traffic areas or near any potential sources of contamination, such as scrub sinks, hoppers, wash sinks, or containers for disposal of linen and trash. Sinks of adequate size for the disposal of liquid chemical disinfectants are also recommended. And again, back to sinks and basins. Some HLD environments I have seen, they're cleaning scopes in a plastic tub or a plastic basin. As long as those, because they don't have the sinks available, but as long as those are being, they're marked out with the proper water line so that they can measure how many gallons of water is in the basin, so that they can measure the proper amount of enzymatic detergents, and as long as those are emptied and cleaned between each use would probably be the best way to work around that environmental challenge. Also, you'd want to make sure that those plastic basins would be large enough to accommodate a flexible endoscope without having to curl it too tightly and cause damage. Now we'll get into the documentation portion for high-level disinfection. The AORN standard states that documentation should be completed to enable identification of trends and demonstrate compliance with regulatory and accrediting agency requirements. So breaking that down is what it's saying is you have your quality controls in place, your auditing paperwork, you're ensuring that all the technicians are filling out the proper times for cleaning, date, time, the instrument, the serial numbers, if they're getting patient information to track with the scopes. Documentation records should include maintaining records of the cleaning of the instruments, such as flexible endoscopes, again, your probes, and information should include but not be limited to, so any or all of the above, the date, the time of cleaning, the instrument that you're cleaning with the serial number of the device, the method of cleaning, number or identifier of the mechanical decontaminator, like which machine or which basin was the item high-level disinfected in is what you're trying to capture. The name of the person or the technician that was performing the cleaning, lot numbers of chemicals that are used, testing results of mechanical instrument washers. That would be in your decontamination area, or any other equipment that's used for cleaning processes, such as like scope buddies, your AERs. If there's any tests, daily tests that are required to ensure that those devices are working, should be documented as well. And then also record of defective equipment and repairs, keeping track of work orders, and the like. According to the AAMI ST58, the cycle documentation and record keeping states that for each chemical sterilization or high-level disinfection cycle, the following information should be recorded. And again, this is very much similar to the AORN standard. All the lot numbers, including the chemical sterilizer or the processor or the soaking container, if it's a manual soaking process, should be documented during the process of the device. Specific contents of the lot or load, including quality, department, and description of items. You want to capture patient name or medical record number, either or, if that's available. But if you are doing high-level disinfection of flexible endoscopes, the clinic or the OR, the end user should be providing you with that information. Sometimes the procedure or physician, if it's applicable, if you do not have the physician name or procedure, the serial number of the device or the identification of the item is appropriate. You want to document shelf life, lot numbers, and the date of the original container of the high-level disinfectant when it was used, the use life of an open container, and the date the product was activated or diluted, keeping records of all of that. Exposure time, temperature, and the chemical concentration of the exposure phase of the chemical sterilization or high-level disinfectant cycle. Again, name of your operator or your technician. The results of your BI, which is your biological indicator if that's required. Normally that's appropriate for your sterilization processes. Your chemical indicator, again, that's for sterilization, or your strip testing, which would be probably more applicable to high-level disinfecting processes. The result of your MRC or your MEC testing, that's usually done depending on the product that you're using. The test strip is done either before the device is immersed into a chemical disinfectant, or if you're using an AER machine, the MEC test strip is done at the end of the cycle, just depending on what product that you're using. And that's for the minimum effective concentration, making sure that the active ingredients in that high-level disinfectant is rendered at its best to ensure that that product is coming out high-levelly disinfected. And then you want to document, of course, any reports of inconclusive or failing MEC results of that, a failed test strip. And again, documentation, the rationale for documentation is it ensures that the monitoring of the process as it's occurring ensures that cycle parameters have been met in order to be able to release those products to sterile storage or rendering them safe for patient use. And it establishes accountability. Documentation helps personnel to determine whether recalls are necessary and the extent of the recalls if evidence of the subsequent lot release, such as a positive biological indicator, a non-responsive chemical indicator, or if a solution test strip or chemical monitoring device has failed, or suggests that sterility or high-level disinfection or there were processing problems. Knowing the contents of the lot or the load enables personnel to decide how critical a recall might be. All right, so now we'll get into a little bit of the staff training and competency in regards to high-level disinfection. The AAMI ST 58 has a section in regarding training and continuing education for personnel. So personnel engaged in any sterile processing or chemical high-level disinfection should receive, one, an initial orientation on the process that they're doing. Also, an on-the-job training, a day-to-day orientation program is recommended. It should be designed to lead to competency-based knowledge and skills in all the tasks that they perform in the sterile processing department or in all decentralized areas that are responsible for chemical high-level disinfection. So this could include your side clinics like ENT or urology, where they're having the medical assistants or other technicians that work on the floor in charge of reprocessing their devices. It should also include an orientation in the facility and department policies and procedures regarding infection prevention and control, safety, attire, personal hygiene, and compliance with state and federal regulations. Addition to the initial orientation, your competency and skills task alignments, you want to perform continuing education, and that should be provided at regular intervals to review and update worker knowledge and skills and to maintain worker competency and certification. Personnel should receive an in-service training from the manufacturer for all new instrumentation, devices, and equipment that are brought into your department, and all orientation and on-the-job and in-service training competencies should be documented in personnel files. All right, so these are some pictures of what I have conducted here in our sterile processing department, especially with regards to high-level disinfection. Again, we were doing a lot of things good, but we had to kind of up our game, especially with all the trends in the news and ensuring that our staff are trained, they're confident in what they're doing, and they're also, we can prove their competency in the tasks that we are asking them to do. So I have discovered, again, that your manufacturers, your vendors, your reps, part of their job is to do in-service training. And so once I've figured that out, I have taken full advantage of inviting those vendors and those reps to come in and do staff in-servicing as often as possible. Especially if we have any new devices, we have new endoscopes purchased by the OR or clinics. We also do certain things for instrument trays. We're also bringing in a different enzymatic detergent. So I'm getting in touch with the manufacturer of that detergent to come in and do an in-service for the staff on contact time, and all the like for even a new enzymatic detergent, just so that the staff knows what it is they're handling and how to use it. So the top 4 pictures was a 2-hour workshop that we did about 2 weeks ago, and I had 2 gentlemen from Olympus come in, and what I did is I pretty much gathered all of the Olympus model scopes that our technicians process on a daily basis. So I had ENT scopes, I had urology scopes, bronchoscopy scopes, a few of the GI scopes that we cover, all the model, anything that was Olympus scope, and brought those to our workshop. And the vendors also brought in, you can kind of see that first picture, they brought in what they call their skeleton scope, which is actually I believe it's a bronchoscopy model scope that has plexiglass, so it's a see-through device. And they can plug that into a scope tower, and you can see the fiber optics light up. You can see the inner workings of that flexible device. So we went through each of the steps of leak testing properly. We went through each of the working channels on the models of scopes that we do, brushing, flushing, suctioning, cleaning, and then the vendors sent me the sign-in sheets. I was able to copy those and put those into their personnel files. And it was actually a really good, informative workshop, and we were glad that they had the ability to come in. But your vendors and your representatives from these manufacturers do have the ability, and they're willing to make themselves available also to all of your shifts. So if you have a 24/7 department, they're willing to come in at different intervals to be sure to touch all of your staff members as well. On the bottom was a workshop that I put together as an initial orientation to our high-level disinfection program, and that was an all-day workshop, and we covered everything from Cydex OPA. We did tests, we did quizzes, we did PowerPoint presentations, and we covered standard work and the like. And also, when we had new AERs come into our department, the gentleman from Medivators came in and spent 2 days with our staff, getting them kind of up to speed and comfortable with using the new machines. So that is available to your organization. So be sure to get in contact with those vendors. I can't stress it enough. Work with them, schedule them, have them come in, and they can help you with that training. Other training tools are just staff-in services. Utilizing your staff huddle times, shift reports, monthly staff meetings in your department can also be other educational opportunities. Again, speaking to the vendor-in services, I found that that's one of the most invaluable keys to maintaining our department's competency. There's other training modules. There's certain organizations such as Steris University online, crazyforclean.com, and also Feidler.com have free training modules and CEU credits for your sterile processing technicians, where they can get continuing education credits also for free for their recertification through ISHM if they hold those credentials. Also, there's a number of training videos from Olympus, from your manufacturers, from ISHM and other organizations online that you can purchase training videos and use those as well in your training program. And then staff training and competency, documenting all of that training. It's a little bit hard to see on this slide, but I put together a tool that I use, the one on the left. It's got my headings, and then each column I have either my date of in-service or my staff meeting. I have my publication source or topic. I also have the details of what was covered, the hour of contact time, and then what the CEU credits would be for that particular training. And I keep this record for each technician in our department, so each person has that either online, and at the end of the year I print off a hard copy that is signed by their supervisors and put into their personnel file. The one on the right is Olympus, so that's kind of a record of what we got that they provide for you when they came in to do their in-service and staff training. So also vendors have their own documentation as well. So I think that kind of brings us to the end of the PowerPoint presentation. I guess we could open it up for questions.
Kelly, hi, it's Jamie Moran. Great job. Thank you so much. I know that was a lot of information. Just want to remind our audience that we will have a follow-up to this with our infection preventionist, Sarah Wilkerson, who's also at Virginia Mason, for more information. But at this time, you've left lots of room for us to ask questions. So if you have a question for Kelly, you can chat into the all participants. Again, all participants, otherwise we may not be able to see it. And if you have a question, you can raise your hand, and we can open your line so you can just ask your question. Okay, so it looks like Fran Peterson, we saw you had a question earlier. Do you still have a question? We can open your line. Christina? There we go. She's open. Fran, if you're on the line, do you have a question for us?
Sure, on the line. I just wanted to know if you do your APT testing after each scope cleaning episode.
We do. We use the ATP tester directly after manual cleaning, just before we put it into the Medivator or our AER device, because we're checking channels of the scope, the distal tips, also the distal ends of our TEE probes, to ensure that I guess within limit, because the Ruhoff tester that we use is a 45, so anything below that number we'll say is clean and ready for the high-level disinfection process. If it's above that number, then we send it back to the decontamination room to go through another round of manual cleaning, because like they said, you can clean a device without sterilizing it, but you can't sterilize or high-level disinfect an item without it being cleaned first. So we kind of make sure that our manual cleaning process has done a good enough job to go on to the high-level disinfection process. And then on occasion, we will pull a scope from the storage cabinet and just do ATP testing as kind of like as an audit check from time to time. And if it's not within limits, we'll, of course, pull that for reprocessing, if that makes sense.
Great. Thanks so much.
You're welcome.
Thank you, Fran. We appreciate that question. We have a question from Joyce Winter, Franklin County.
Medical
Joyce, go ahead.
Am I on?
You are.
So my question is, you mentioned in your presentation, Kelly, that you have to have a cabinet to put your scopes that have been cleaned to hang in there. And I've heard conflicting information about, yes, we do, no, we don't. And so I want you to repeat that because I want to make sure that we get this right.
Okay. Usually, always double check your manufacturer's instructions for use. So whether you have like a Pentax scope, you have Karl Storz, Olympus, Fujinon, whatever model of scope that you have, look at the manufacturer's instructions for use. Sometimes it's very vague in general, so it's hard to get that specific answer. If I'm unclear with the manufacturer's instructions for use, then I call the company. I make a phone call. But also what the ST58 or your ST79, AORN, APIC, all the regulatory agencies, their recommendation is that if you're not immediately using a scope right after processing and it's going to go to storage, they recommend that flexible endoscope is stored hanging vertically in a scope cabinet with like the buttons, the valves, and the water-resistant cap removed, because if it's curled up in a transport container and left, it has the potential to be an environment where it's possibly going to start growing those bugs in the working channel. It's putting that scope at risk. And so we have found certain scopes like actually still left stored in the manufacturer's suitcase. And so we've had to go to departments and have critical conversations telling them that it's not, the suitcases are not appropriate for storage of the device. So the recommendations are to have that scope hanging vertically in a scope cabinet to protect it, first of all, because it's such an expensive device. Also to put it in an environment where it's going to that high-level disinfection process, because remember, it's not sterile, it's just high-levelly disinfected, but you want to put it in an environment where you're going to maintain that level of cleanliness and high-level disinfection as best as you can. We also have, I guess, the controversy of, well, can we just leave it stored on the scope tower hanging off the side? I would say if you go to do that scope tower is put in a place that is not in a busy access way, like in your sterile core in the OR or something, you have a scope tower, but yet that's such a busy thoroughfare, so to speak, just because that environment is hard to maintain. I don't want to say sterility because it's not a sterile device, but if it's you want to keep the device as clean as possible and far away from it being contaminated before use. Does that make sense?
Yeah, it's perfect sense. It's just sometimes getting it done is a problem.
It is, and it's and having these conversations with I guess your key stakeholders, and explain to them, look, we have good practice right now, but what we're trying to aim for is best practice, and our patient should be our highest priority, and so we're wanting to give them a device that the high-level disinfection process of that device has been maintained before it was used on them, if that makes sense. So I guess it's just trying to get your, I guess, key stakeholders in these departments kind of on board. So usually there's a lot of roundtable discussions and the like. But if you can find your publications and pull out your recommendations and say, these are what these regulatory agencies are recommending, because CDC is confirming superbugs, cross-contamination. You can find articles to support this push to having a scope cabinet. If that makes sense.
That's perfect. Thank you so much.
Welcome.
Thank you, Joyce. We appreciate your question. Anybody else want to chime in or ask Kelly a question while we have this opportunity? I will say that Lisa Hanna has asked Kelly if you'd be willing to share a copy of your competency document.
Sure. My competency document, I actually stole shamelessly from the, is it CBSPD? Is that? It's another sterile processing certification. It's called CBSPD. That's their, I guess, Excel version. But I can share what I've put together. I just changed the headings to match what I needed for my department. But I'd be more than happy to send you my template.
That would be great, Kelly. Thank you. So again, this is Jamie. Kelly, if you send me your documents, we'll get those sent out, and we'll certainly get them posted to our new collaborative site.
Good.
Any other questions? So Kelly, this is Jamie. Early on, you had a slide that talked about how to assess your products, and one of the questions you asked was about employee health records, how long they needed to be kept. What is your recommendation on who should be the authority to answer that question?
That might be a Sarah Wilkerson question, actually, because I'm not positive. It's one of the recommendations in the ST58, that Amy Anstey publication, but I'm not positive. I don't know. What would be that? I'm not positive, to be honest.
Okay. Maybe Sarah can chime in and see what her recommendation might be.
So I would recommend consulting with your legal department because they may have specific guidelines, but in the past, you pretty much keep them forever.
Mm-hmm.
And I would second that. I think in some of the past experience, it's always a good idea for you to collaborate with your employee health department, your risk management department, and as Sarah said, if you have a legal department or human resources, for example, they will have some guidelines and policies on employee health records and where those need to be kept. So we appreciate you helping us to think through the process. A lot of our infection preventionists will sit on product evaluation committees, and I think Sarah's going to be able to talk a little bit about that next week as well. So we really appreciate you telling us kind of the things to think about. So Lisa chimed in and said she thought the length of employment plus 30 years was how long you had to keep employee health records. That's a long time. That may be correct. But I would definitely check with your institution's policy and make sure that you're following that. Well, we have about 2 minutes left. If we don't have any other questions, we'll give you back a few minutes of your day. Again, if you have follow-up questions, feel free to email them to me, and we'll get those passed on to Sam and to Kelly and to Sarah. We hope that you will join us next Thursday, October 8th at noon. Sarah Wilkerson will present the infection preventionist role in assessing high-level disinfection. So Sarah's going to try to walk us non-sterile processing techs through the process of what we should be looking for and how do we know whether or not the processes are effective. So hopefully we'll see all of you again next week online. And thank you so much for joining us today.